So in order to interpret the line of best fit, we're going to focus in on two concepts today: drawing the line of best fit and the prediction from the line of best fit. Okay. When you draw the line of best fit, here are some guidelines. Number one, the line should follow the trend correlation. So you're deciding whether you're going up in a positive direction or down in a negative. Okay, the line should go through as many points as possible. There should be an even number of points above and below the line. Okay, what does that mean? That means if you're going to try to draw this line between the points and intersecting the points, and you want to have the same amount above and below. So in this case, you have 1, 2, 3, 4 points below the line, or 4 points above, and also 1, 2, 3, 4 below. Okay. In this line, it doesn't actually go through any of the points, and that's okay. Your goal is to try to make the best line go through the center. Okay. The line should pass through points throughout the line, not just the beginning and the end. Now, keep in mind, these are not all requirements. These are just some guidelines, just some general ideas. So it doesn't have to start and go through this first point, and go through the last point. It doesn't have to go through the first and last at all. Just trying to get in through the center of the information. So let's look at this example. If we wanted to graph the line of best fit, we have to figure out where to click so that we can get the line between as many points as possible. We don't have to count these to make it exact. We just want to try to eyeball it to figure out, okay, so where would we start? Okay, so if I look and I think, okay, here is like the middle, is if I think about going up the middle, that's where I'm seeing. So then I'm going to try to plot that so that it goes through the center. And I can count to make sure that I'm close. I just saw a natural gap to kind of help me split these data points. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 on the top, 1, 2, 3, 4, 5, 6, 7, 8, 9 on the bottom. That's pretty close. Like I said, it's not going to be perfect to have the same amount on the top, the same amount on the bottom. But that's your goal, is to just try to split it. By drawing the line of best fit, you're trying to split the data. Okay, and then they say, okay, this is where the computerized version thinks the line of best fit would be. All right, same. My line was shown on green. That's what they show is a little bit better. Okay, so just staying with the trend. It's not going to be perfect. Okay, just do your best. We have another line. We see all of these data points representing data, and we're trying to draw a line of best fit. So I see, if I draw a line in here and try to split those, that kind of splits them. But notice my line does not go with my data at all. It's not going between half the points continuously. You're trying to get it, so this one has a negative correlation. So it's slanting downhill. So I want to get rid of that. I don't like the way that line goes. So I'm going to move that a little bit. Here it doesn't seem, so I'm trying to tilting it. Yeah, it goes through this way. But notice that line still is not centerish. So I'm going to grab it some more and continue moving it until I feel like I'm getting it centered. Okay, and then I look and see, okay, where's that? I even like to count my points and think I have 3, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think I can do better than that. Okay, so maybe even click and plot those points. Grab those. You're trying to get the data as close as you can. I think that's about the best that I can do to center up that information. So then I like to check it. And they show mine as the green line and then the computerized one. I'm close. Okay, and they mark that as close enough. So the goal is just to get it close and in the right direction on these problems. Next, we're going to use a line of fit that is given to make predictions. Okay, so we have a scenario here. Parker has a part-time job at an ice skating rink selling hot cocoa. he decided to plot the number of hot cocos he sold relative to the day's high temperature, and then draw the line of best fit. So he drew the line of best fit. Based on the line of best fit, how many hot cocos would you predict Parker to sell if the day's high temperature were 15 degrees? Okay, so understand that each of these points represents the temperature of the day, the high temperature of the day, and the amount of hot cocoa sold. So if the high temperature in Fahrenheit was 10 degrees, he sold 94 cups. If the high temperature was 11 degrees, he sold 97 cups. So each one of these data points represents something that happened when he was selling hot cocoa. So our goal is to figure out the price, or how predict how many they're sold on the day's temperature was 15 degrees. Notice the 15 degrees is not on here. So let's think about, so we can kind of draw this in to help us understand. So if we were wanting 15 degrees, we would think, okay, 15 degrees is going to be off. We can keep extending this. So you'd have 13, 14, maybe 15 here. Okay. Okay, so then we could say, we could draw that in and we could just extend that. And that gives us a great indication of where it would be. I would say, okay, if I'm up here, over here, it's probably given us close to 93. We can plot a little point there and have an idea, run over to the y-axis. But there's a more specific way we could do that. We could actually figure out the slope of this line. So given those 2 points, you can go down 1, 2, go down 2 over 1, 2, 3, 4, 5, down 2 over 1, 2, 3, 4, 5. See if we can go down 2 over 1, 2, 3, 4, 5. We would intersect right there at the 15 degree mark. Okay, so you can use just eyeballing it to get your measurement, to get your answer, or you can actually look at the slope, your rise and your run. Okay, remember you can always find distance by looking at the rise and the run. So based on this, I would say I am fairly certain that he would sell 93 cups of hot cocoa. Down, and then you submit your answer. As always, make sure you read your feedback, and then they also show you using the rise and the run as well, and the detailed explanation, okay? All right, let's look at another example. Okay, so on this one, a researcher studied the relationship between the number of times a certain species of crickets will chirp for 1 minute and the temperature outside. Oh my, this is definitely one that I remember seeing in school. Her data is expressed in the scatter plot and the line of best fit below. Based on the line of best fit, what temperature would it most likely be outside if the same species of crickets were measured to chirp 112 times in 1 minute? Okay, so let's look at our graph and let's look at the information that's being provided here. We have chirps per minute. So chirps, that's the number of chirps in 1 minute because it says per minute. Okay, and then the temperature outside. So we're trying to find the temperature if it were to chirp 112 times. I don't know who sits around and counts the chirping of crickets. But where would 112 be? So we can use our estimate by looking and thinking, okay, well, where is 112 going to be? These are being grouped in groups of 4, so that'd be 8, 12. Okay, 112 would be around there. If I look, because I need to make sure I'm following the same interval, otherwise my spacing might not be correct. And then so it would go over 2 columns, okay? So I'm going to go up, and I would think it's going to be about right there, okay? So if I think about how that's going to go, if I follow that graph up. So I could look at my line, and I can kind of estimate this to be 62, 63, 64, 65. I would think it's going to go up 2 because it went over 2, because I look at the pattern over 1, up 1, over 1, up 1. So it's going to go over 1, up 1, which would be at 64, over 1, up 1, which is going to be at 65. So you can figure that out based on looking at the pattern. Notice the lines going over 1, up 1, over 1, up 1, over 1, up 1. So you would do the same thing. We know we need to go over 2, so we need to go over 1, up 1, and over 1, up 1 again. And then these would be in intervals of 64 and then 65. Okay, check that. So we did find that out. So yes, they showed the intervals going up 1, over 1, so that we're seeing the interval between the chirps per minute and the degrees, tracking that. Notice it's not perfect. Just because that's where the line of best fit goes, that's not where all the data points go. So that means we can't exactly figure out how many times the cricket's going to chirp because the data is not following directly on the line. So this is just a useful tool to help us make predictions, which is what statistics is all about, making predictions using data. So they just kind of said, okay, well, let's extend that line. So we took a section of this graph and extended it. Okay, notice the first graph stopped at 63, and then they expanded it and made it expand and showed going up 1 over 4 degrees, up 1, and then over 4 degrees. Okay, so based on that, we can predict that if the crickets chirped 112 times per minute, it would be 65 degrees outside. But make sure you're understanding this is a prediction. We're using the data to make predictions on these lines of best fit. All right, go ahead and go through your homework. If you have any questions, let me know.